Okay, so this is my 4th time teaching this lesson, but I am recording this for the people who are gone yesterday, today, whatever, that didn't get this lesson at some point. So, section 1.8 is 3D figures. The other day we did 2D figures, two-dimensional figures. Okay. 3-dimensional figures are called polyhedrons. You guys remember yesterday, or the other day when we had 2-dimensional figures, what those were called? 3D figures are polyhedrons. What's a 2D figure called?
Dihedron?
Nope. Polyhedron. Starts with the same word. What are 2-dimensional figures? Polygon. Jerome, thanks for your help. Polygon. Jerome's already had this lesson. So polygon. They are polygons. Now, polygons, if you remember from the other day, are not circles. So they are not rounded things, not circles. Same thing with polyhedrons, kind of, except polyhedrons are not cylinders, because cylinders have rounded edges. They are not cones, because cones have rounded edges, and spheres, because spheres are rounded edges. Okay, so these are non-polyhedrons, although we will talk about them because they are special. But polyhedrons are 2 different types. They are prisms or they are pyramids. Prisms, pyramids. So, let's talk about prisms versus pyramids. This is a prism, by the way. He is a pentagonal prism. Pentagonal prism. Okay? And this guy is a rectangular pyramid, because they are named by their bases. Okay? So, let's name some differences between pyramids and prisms. What do you got? What are some differences? What? What? They're kind of pointy, so they come to a point, right? The sides come to a point, whereas they don't do that on prisms. Okay? Let's talk more about the sides. What are the sides of a prism or of a pyramid? Sides are triangles. What about the sides over here? Sides are rectangles, right? You see how the sides are rectangles? Okay, let's talk about the bases. The bases of each one of these. What do you notice about bases? But it doesn't necessarily have to be a square. You can have a pentagonal pyramid like this one down here, right? This one's a pentagon as his base. So it doesn't necessarily have to be a square. Let's talk about how many there are. How many bases does a prism have? 2. 2 bases. 2 bases that are parallel. Okay, the 2 bases are parallel to each other, meaning they're flat, even, flush with each other, right? Okay, 2 bases that are parallel. What about the bases of a pyramid? 1 base, that's it. 1 base, the bottom, usually, right? Okay, so all of those. All right, so cylinder, cone, sphere, bases, pyramids, prisms, all that good stuff, okay? I have so if you're watching this video, sorry, you don't get to incorporate, or you don't get to have fun, but whatever. We are going to, you 3 who are listening, or watching this, you need to separate these guys out. So put all of the non-polyhedrons in this category. Put all the prisms over here and the pyramids over here. Prisms, pyramids, non-polyhedrons. Prisms, pyramids, non-polyhedrons. Yeah. Prisms, pyramids, non-polyhedrons. Prisms, pyramids, non-polyhedrons. Prisms, pyramids, non-polyhedrons.
Right now?
Okay. watching this video, hopefully maybe you just fast forwarded through that, but here's this. They said that these shapes that I'm about to show you are non-polyhedrons. This guy right here, what is he? What is this shape? That's a cylinder. Same thing with this guy, right? Cylinder. And this one's the same thing, a cylinder. Okay, what about this thing? What's he? It looks like it has a bite mark. I'm pretty sure that's my toddler that did that. You see that little bite mark? Yep, those are my like kiddos' 2 front teeth. Let's see if we can find the other one. Maybe she bit right there too, maybe, or something. I don't know. Anyway, there's a sphere. What about this thing? What is this? What is that? Half a sphere. Do you know what a half a sphere is called? Think of science and social studies. What's a half a sphere? Oh, a dome is a good word. That's not the word I'm thinking of. We are in the northern one of these.
Oh,
Hemisphere, right? So your book might call it a hemisphere. Okay, there's another bite mark out of that. What the heck, kiddo? Okay, what are these? Cones. Cones. None of those are polyhedrons, though, because they have rounded edges. None of those are polyhedrons. Okay, now. You just mixed them up again. Mixed them up. Okay, these two are called what? What are these two? They're rectangular pyramids. Rectangular pyramids, right? Those are pyramids. Okay, let's go to the other one. Oh my gosh. I had a huge step. Okay. The rest of these are called what? What are these that you just gave to me? Prisms. These are all prisms. Okay? So, prisms. This guy is a, what kind of prism? Rectangular prism. This guy is a? Rectangular prism. This guy is a? He is a rectangular prism. He is also a square prism or a? What is he? Cube or cube. He has 3 names. So he's a rectangular prism, he's a square prism, or a cube. Same thing with this guy. He's a cube also, right? But he's just wooden. Okay. All right. What about this one? How many sides? Nope. Hexagonal prism. Has a hexagonal prism. Okay. This one is a octagonal prism. Okay. What about this thing? That's a triangular prism. Okay. The bases are 2 triangles. I had some people try to like put him like this and say that he's a pyramid because it comes to 1 point. Okay. If he was a pyramid, he would come like these sides would come up to 1 tip here, right? It would come up to 1 tip here. So this is a triangular prism, and the sides are rectangles, right? Okay. Same thing with this guy. He is just shorter and fatter. He is a triangular prism, right? That's what he looks like. Okay. Now, here is the deal. When you have like a shape like this guy, the bases are only going to be these 2 hexagon shapes, right? Only this one and the bottom one. Okay. Now, even if I set him like this, okay, if I set him like that, these 2 are still the bases. So it doesn't necessarily mean that the base is the top and bottom. The bases are the bases. Basically, the bases of a prism are the ones that are not rectangular, right? These are all rectangles around the sides here, right? These guys are not rectangles, so those have to be the bases, yeah? Okay, now, if you have a rectangular prism like this guy, rectangular prism, he is really nice for the fact that you can choose which ones are the bases, right? Because all the bases are rectangles and all the sides are rectangles. So if I want to, I can say the top and the bottom are bases. Or I can flip him this way and say that these 2 are bases. Or I can turn him this way and say that this one and this one are bases. Does that make sense? I have options for a rectangular prism as to which ones are the bases. Versus like ones like this, where those ones, the only bases are the top here and the bottom here. Or if it's flipped on its side, these 2 right here. Okay? So not necessarily top and bottom, but this is the only option that I have. For a rectangular prism, I can call anything the base. Okay? As long as they're opposite each other, right? Okay, so there's that. All right, so we just went through. They list them on here. A triangular prism. These are rectangular prisms, pentagonal prisms. There's more than just that. These are all pyramids. So this is a triangle, rectangle, pentagonal pyramid. All of those. Okay, now, ABC, they want us to determine whether each is a polyhedron. Okay, polyhedrons don't have rounded edges. So which ones are yeses and which ones are nos? A and C are yes. Yes, yes. What about B? What is B? What shape is B? They want us to name them. He is a cylinder. Okay, now let's name A. What is A? He is a rectangular prism. Okay, what about C? What is the name for C? He is a triangular. He is a triangular pyramid. Okay, triangular pyramid. Okay, so we have determined whether each solid is a polyhedron. Yes, done. Identify the solid. Yes, done. If it is a polyhedron, so only if it's a polyhedron. If it's not a polyhedron, we don't have to do anything. So B is done. But if he is a polyhedron, we have to name the bases, the faces, the edges, and the vertices. Disgusting. Disgusting, okay? Bases, faces, edges, vertices. I'm going to leave a lot of room. Now, on your homework assignment, I altered the instructions because I am only going to make you do one problem where you list them all out. Okay? The second problem, I'm just going to have you tell me how many there are. Bases, faces, edges, vertices. So on all of the rest of them, you're just going to tell me how many there are. Okay? So bases, all right? This is a rectangular prism, so we get the option. Do you want the top and bottom to be your bases, the front and the back, or the two sides to be the bases? Which ones do you want? Top and bottom, sure. How do I name this top side here? This is a rectangle on the top. How do I name that top side? What? N is this dot down over here. Do you see that? Q is this top dot over here. Yeah, I had a lot of people do that. How do you, so Q is this guy right here, N is that guy right there. So those are just naming the vertices. What? S, R, Q, T. So he says S, R, Q, T. That shape, S, R, Q, T, is a base. Yes, that will work, okay? You could name him S, T, Q, R, but make sure that when you start naming him, you go full circle, right? So don't call him S, Q, T, R, right? You want to make sure you go in a circle when you name him. I don't care what letter you start with. Okay, the bottom. What's the bottom going to be named? NMPO. NMPO. That will work? Sure, sure. Okay. Two bases. Done with bases. All done. Faces. All of the faces are all of the 6 sides. Okay. Bases are included in the faces. So I'm going to just repeat those two that we have up there. SRQT and NMPO. Those are also faces. Then we have 4 more faces. So we have like this front side right here, this side right here. What's the front side? What's this guy named?
QPOT.
QPOT. That will work. QPOT. What's this side right here? RMPQ. Sure. RMPQ. This back side up over here on the very back. Go SNMR. Make sure you go in a circle. SNMR, right? SNMR. You want to go full circle. And the last one on the back side over here. SNOT. He did it in the way that I wanted him to. Snot, huh? Funny. SNOT. Okay, edges. Oh my gosh, edges. Yuck. I need a different color. S. All right. Edges. Edges. Edges are where 2 sides come together. They're basically the lines. So, like, I'll give you an example. QT is an edge. This guy is an edge. QT. Okay. What's another edge? Let's go around the top. QT is an edge. TS. It doesn't matter what order you go in for these. TS. Okay. SR. And RQ. Okay. It doesn't matter what order you go in, but it's kind of nice to do like all of the tops first, all of the bottoms next, right? So let's do all the bottoms next, starting with PO. PO, okay? Then what's this one over here? ON, okay? And then NM, and MP. That's all the ones around the bottom. Done? No. We've got these little guys right here. Like QP is one. Okay? This one right here. TO or OT, doesn't matter what order you put them in. SN and RM. Okay? There are 12 of them. All right, vertices. This is the easiest one of all of them. Vertices are the corners. So name me a corner. Just S. S is a corner. What's another corner? N. Okay. What's another corner? What? T and O and Q and P and R and M. We've listed all 8 of them. Okay, good. So there is one homework problem that I make you list all of those out on. The rest of them I have you do like this next one that we're going to do. Okay, can I go to the next page, the next side? Over here? Okay, how many bases does this pyramid have? One, because he's a pyramid. How many faces are there, like flat surfaces, including the base? 4, including the base is 4. So the front, or these 2 sides, the back side, and then the bottom. That's 4. How many edges are there? There are 6 edges. This one, this one, this one, this one, this one, this one. There are 6 edges. How many vertices? 4. There are 4 points. Good? Make sense? Yes? Okay, now, you guys have some shapes in front of you. You might have to share. M's got some of them, and you guys have the other ones. But, regular. Do you guys remember what regular meant from when we did polygons? What is a regular polygon? If they say a polygon is regular, like if I say a regular pentagon, it's not just any old pentagon, it's a regular one. What does regular mean? Equal sides and equal angles. Right? That's what regular means. Equal sides, equal angles. Okay, so they have some cool shapes called Platonic solids. Okay, Platonic solids are made entirely from regular figures. So this guy right here is a regular triangle because all of the sides and all of the angles are exactly the same. And what they've done is they've taken that guy and they have made 4 of them put together to make this Platonic solid. Does that make sense? There are 4 regular triangles all smushed together in one shape to make a tetrahedron. A tetrahedron. All right, now this guy and the middle guy, this is a made from regular triangles, okay? A octahedron has 8 sides, but those are also made from regular triangles. So if you look at this shape right here, you guys have this shape in front of you, somebody does? Maybe M, maybe you guys, okay? One of you guys has this in front of you. But they are all made from regular triangles, but there's just 8 of them all combined together. That is an octahedron, right? An octahedron, okay? So those are made from regular triangles also, okay? Now, same thing with an icosahedron is what it's called, and that's the other black one, okay? The other black one with 20 sides, and those are all made, again, from regular triangles. Triangles where all the sides and all the angles are the same, okay? So, that is an icosahedron where it has all of these. Elena Cox was telling me this morning that this icosahedron is what is inside of a, you know, one of those 8 balls that, like, you shake them and they give you your fortune, right? If you break them open, which is what she said if you break them open, it has one of these inside of it, an icosahedron, where, like, all the messages, there's like 20 messages that you could get, right? Yeah, there's an icosahedron inside of that. So, that's exciting. All right, now, so those all are made from regular triangles. Now, this second one is a square. This is a cube. He is also made from regular shapes. So if you think of a cube like this guy has all squares, which is a regular figure. A square is a regular figure because all the sides and all the angles are the same. So that's a cube. He's kind of boring, okay? Now let's go over to this one right here. A dodecahedron is the green one. You might have a green one in front of you. What are those? What shape makes up those?
Pentagon.
Pentagon. That's a regular pentagon. All the sides and all the angles are the same in that pentagon. And there are 10 of them. No, wrong. How many are there? 12. 12 of them. This is a soccer ball. This is a soccer ball. Okay, now, this is a little bit more lumpy than a soccer ball, right? This has more edges because soccer balls are made entirely out of, like, fabric, right? Or like like malleable material. So these, on this shape, these pentagons are all flat, but if you make them out of material, they start to bend, so the pentagons aren't completely flat on a soccer ball, right? But this is exactly what a soccer ball looks like with all those pentagons on him. He's just a little bit flatter because his edges aren't pokey, right? That makes sense? So each one of these is kind of fun because they're made from regular polygons just all shoved into one figure. Those are called platonic solids. Platonic solids. I won't ask you too many questions about platonic solids. Those are just kind of fun. So, all right, now, for these guys, surface area and volume. We have 4 or 5 different shapes, and we have surface area and volume for each one, okay? All right, they write surface area. They write surface area as T, but I'm going to change him each one to say SA instead of T because I don't like T. I want SA, okay? And then V is volume, 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 volume all the way across, okay? All right, for the purpose of this lesson, I am only going to have you, or this chapter, I am only going to have you know how to plug stuff into this formula. I am not going to make you memorize any formulas until we get to the end of the school year, which is chapter 11. Then we start to do this kind of same thing again, and I do make you memorize some of the formulas, okay? So get used to some of these formulas now, and maybe start memorizing some of them or start learning why the formula is set up the way that it is, and then it will be easier for you come springtime, but I won't make you memorize anything until chapter 11. So in this prism, when you're trying to find the surface area of this rectangular prism, which looks like this, it's one of these guys, okay? You are trying to find all of the surfaces added together. I'm really blurry, sorry. You're trying to find all of the surfaces added together. They've come up with a shortcut, and they said that if you're finding all of the surfaces and adding them together, that is like taking the perimeter of the base times the height. Capital P means perimeter of the base times the height, and adding to, what's capital B mean? Area of the base. Capital B means area of the base. So and adding to area of the bases. These are all 4 sides. That's where this is incorporated. And this is top and bottom. Okay, so the 4 sides make up this part of the equation. The top and the bottom make up that 2b part. Okay, the volume of a prism is the area of the base times the height. Some people like to write volume of a cube as length times width times height, right? Because the area of the base is the area of a rectangle, which is length times width, right? Okay. So rather than writing as area of the base times the height, they write it as length times width times height. Okay. Now, take a look at the volume here in comparison to the regular pyramid. What's the difference? What's the difference between volume of a prism and volume of a pyramid? 1/3. This guy's a third of what he was before, okay? So they're saying that, here's my prism. They're saying these two right here, okay? They're saying this guy is a third the volume of what this one is. What? That's the rule, okay? So we know how to find the volume of a prism. We know how to find the volume of a pyramid. But then the surface area is a little bit different. So 1/2, capital P. What does P mean again? Perimeter of the base. What does the L mean? It's not length. It is, look at your key code, slant height. Okay, what the heck is slant height? Let's look down here at this pyramid. There is a difference between height and slant height. One of them is 4 and one of them is 5. Which one is the slanted height? 5 is the slanted height, so I'm going to label him with L. That's what they mean by slanted height. What is 4 labeled as then? What is 4? What? No, because that would be a circle. That's just regular H, right? So you have height and then you have slant height. Okay, so 4 is the regular height. All right, and then you have in the formula also you have a capital B, which means the area of the base. All right, so use this little key code down here if you don't know for sure. For a cylinder, 2 pi r h. This gives you the side, or I'm going to call it the soup label. You guys know what I'm talking about by the soup label? Soup label is the area around the side here. And then 2 pi r squared is top and bottom. Okay, so 2 pi r squared it gives you the area of the top and the bottom. The 2 pi r h gives you the soup label. Okay, and then volume is pi r squared h. Okay, for a cone, pi r. What's this L mean again? Slant height. Okay, and pi r squared. This is the bottom, and this guy is the sides. Okay? 1/3 pi r squared h. Check out the volume of the two of those. Volume of a cylinder versus volume of a cone. What's the difference? Volume of a cylinder versus volume of a cone. What's the difference?
1/3.
1/3. It's the same as a prism and a pyramid. So they're saying that this cone, oh man, I have shapes rolling all over the place. This cone and this cylinder, they're saying that this guy is 1/3 of the volume of this one. Okay, that's what they're saying by that formula. Okay, and then we have a sphere, and a sphere for surface area is 4 pi radius squared and 4/3 pi radius cubed, which is kind of weird, but that's the volume for a sphere. Okay, all right, let's go do some examples. So find surface area and volume of this square pyramid. There's a really important word in there that helps me identify some things about this.
Square.
Square, what does that mean? All the sides of the base are the same. So if this side is 6, then this one is also 6, and this one is 6, and this one is 6. Okay, so there's all 4 sides that are 6s. All right, so they want us to find surface area, and they want us to find volume. On your homework assignment, I would encourage you to rewrite the formula. So we are looking for a pyramid, which is this formula up here. So I'm going to recopy the formula down below. 1/2 perimeter of the base times the slant height plus the area of the base. That's what he is, okay? And the volume is 1/3 capital B times H, okay? And now all I have to do is just plug stuff in and get an answer, right? So 1/2. Capital P means what? What does capital P mean again? For my formula? The perimeter of the base, okay? So what is the perimeter of my base? 24. 4 sides with 6 makes 24. And what's the slanted height? That's what L is. 5. Okay? Capital B means the area of the base. So if they're 6s, what's the area of the base? 36. Beautiful. Okay? Now, you can do this in your head. Do this in your head if you can. 1/2 of 24. What's that? 12. What's 12 times 5? 60, and 60 plus 36 is 96. Units are in centimeters. We are doing surface area. Surface area squared, centimeter squared. There we go. Okay. All right. Volume, 1/3 the area of the base. That's what capital B is. Area of the base is 36. 6 times 6 is 36. What is the height? 4 or 5?
4.
4 is the height. Okay. Now what's 1/3 of 36?
12.
12. What's 12 times 4? 48. And that guy is in centimeters. We're dealing with volume. What's the units on volume? Do you remember? No? Cubed. Volume is 3-dimensional, so it is cubic. Okay. Volume cubed. All right. Next. Go down to example 3. It says, Joanne is making noisemakers out of rice and empty paper towel tubes. Have you guys done this before? Or made like telescopes or whatever out of paper towel tubes? Yeah. So you're putting stuff in it to make noise and you're shaking it back and forth. This paper towel tube is 12 inches long. So I'm going to go like this. 12 inches from there to there. Okay, and then it says the diameter is 1.5. So from here to here, that's 1.5 inches. Okay. Now, none of our formulas involve diameter. They all involve radius. So if my diameter is 1.5, what will my radius be? 0.75. It's half of that, right? Okay. Now, what shape are we dealing with, by the way? A cylinder. Okay, so I'm going to write that off to the side so we can remember what we're doing. All right. It says it wants me to find the surface area of the noisemaker, okay, and the volume of rice needed to fill the noisemaker 1/4 of the depth. What does that mean? Here we go. Let's just do surface area and let's just do volume. We'll just do those regular old surface area volume and then we'll worry about the 1/4 of it, okay? So surface area of a cylinder, if I go back up to the formula up above here, it is this guy and this guy. I'm going to recopy them down. So surface area is 2 pi RH plus 2 pi r squared. Okay, that's what he looks like. Volume is pi radius squared times height. Okay, that's what he looks like. Okay, and I'm going to split these down the middle. So I do volume on one side and surface area on the other side. So surface area, when I start to plug stuff in, 2 pi stays 2 pi. The radius is, we said 0.75. What's the height of this thing? What is the height? 12, right? Even though this guy's laying down, the height is still like 12 because imagine that you put that paper towel tube up on its top. 12 would be the height. Plus 2 times pi times 0.75 squared. Okay, this is where we need a calculator. We can do some of it in our head, but we can't do this. $60.08. Okay, now they want to the nearest tenth. How many decimals is to the nearest tenth? Nearest tenth is 1 decimal. Okay, so 60.1. And that is labeled in inches. We're finding surface area, so inches squared. Inches squared, that's 60.1. Okay, now volume is pi radius squared times height. So we just need pi times radius is 0.75. Height is 12. Oh, we need squared. Pi times 0.75 squared times the 12. That is something. 21.2. Right? 21.2? Gosh, I'm so smart. Except this is my 4th time doing this lesson. So I'm really not that smart. Inches. Volume. Cubed. Okay, now, here's the deal. We are only filling this paper towel tube a 1/4 of the way. If we're only filling it a 1/4 of the way, is that going to deal with the overall surface area? Is that going to change my surface area? No, because you still have the paper towel tube. But is it going to fill the volume of it inside? Is it going to change that? Yes. So what do we need to do if we're only filling this a 1/4 of the way full? We're going to divide it by 4 because these are only going to be filled a 1/4 of the way. So 21.2 divided by 4 is 5.3. So we only are filling it 5.3 cubic inches. So there's 5.3 cubic inches of rice in that thing. Okay? All right, last one. The diameter of the pool Mr. Santo purchased is 8 feet. Okay? 8 feet in diameter. But we don't deal with diameter. We only deal with radius. What's the radius? 4. Okay? The height of the pool is 20 inches. Problem. Uh-oh. One's in inches, one's in feet. Poop. Which one would you like to convert to? Would you like to go inches to feet or feet to inches? You want to go feet to inches? So 4 feet is 48 inches. Okay, so we're going to say the radius is 48 inches. Okay? All right, so we need to have both units in the same, or both measures in the same units, okay? Find the measure of each to the nearest tenth. We're doing surface area and volume. So surface area, volume. Okay, here's the problem. Let's go ahead and write the things down. What shape do we have here, by the way?
Cylinder.
He is a cylinder, right? I had somebody ask this morning, like with the poles down the middle, is that changing like his shape? That's just supporting it, right? Those aren't like changing the vertices. So he doesn't look like this, right? Like those aren't the poles. You don't have a hexagonal like shape, right? He is still going to be a circle. Those are just supporting the outside. So he is still a cylinder. So surface area is 2 pi RH plus 2 pi r squared. Okay. Volume is pi radius squared times height. Okay. Now, here's the deal. Pools don't have a cover on them unless you put a cover on them, right? But like in a normal swimming pool, he does not have a cover. So that's going to affect which one, the surface area or the volume? Surface area, right? If he has a cover on him versus not a cover, it's not going to affect how much water he's going to hold, right? But if he doesn't have a top, his surface area is going to be different, okay? So the top here is what shape? What shape makes up that top? A circle, okay? So I basically need to subtract out the area of that circle, right? That goes on the top. What is the area of a circle? Just pi r squared, okay? Just pi r squared. So basically this pi r squared, that's 2 of them, only goes to 1. Does that make sense? Because now he only has 1 base. He's got the bottom, but he doesn't have the top. So instead of having 2 bases, he has 1 base. Does that make sense? So we do need to change our surface area just ever so slightly, all right? So let's go ahead and plug into our formula now that we've altered that, okay? The radius we said was 48. Height is 20. We're going to end up with some big numbers here. Plus 1 times pi times the radius is 48 squared. We're going to end up with a huge number, but it's going to be in inches squared. I think this morning we converted, maybe it was yesterday, we converted to feet first. Oh, yesterday. We did your class. Yep. So yesterday when I taught this lesson, we converted to feet. It doesn't matter. You get the same answer. I mean, not the same answer, but you'll get an accurate answer regardless. So 2 times pi times 48 times 20 plus pi times 48 squared. 13,270.1. See if McLean concurs. To the nearest tenth, 1 decimal place, we did it right. Perfect. And that is in inches. Surface area? Squared. Inches squared. That's what he is. Okay. Now, volume. He's going to hold the same amount of water regardless of whether he has a top on him or not. So pi times radius is 48. Squared times height is 20. Okay. So what is that going to be? What? 764? Is that what you said? 764 inches. Oh, 0.6? 0.6 inches cubed? Is that what you got, McLean?
Yeah.
Now, is it always true that the surface area is smaller than the volume? Look up here at the top. Was my surface area smaller than my volume up here? No, I had Lily. I'm going to pick on Lily. Sorry, Lily. Pick on Lily. She came to me the other day and she's like, I don't think this is right because my surface area is smaller than my volume. That's okay. Especially since we deleted the top out, right? Okay. Now, this volume is basically the volume of water that can be held by this pool if you fill it to the brim, right? Like most pools, you don't fill all the way. You leave like 6 inches maybe or 4 inches, whatever. But this is what volume of water could be held if you fill it completely to the brim. Okay? All right, here. Let me give you your homework assignment. I got some, don't shut this video off if you're watching this video. I got some altered stuff for your homework assignment. So don't shut this video off. Okay? Yeah. So take a look at this real quick with me. Are you guys on practice side? On practice side. I told you I was going to only make you name bases, faces, edges, vertices, blah, 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 for one of them. That is number 1 on practice side. So you have to name the bases, faces, edges, vertices, right? If it's not a polyhedron, you don't have to do anything except say no and name it, right? So number 2, is he a polyhedron? No, he's a cylinder, so that's all you put, no cylinder, okay? Number 1, you're going to put yes. What is he? He is a pentagonal prism, and you're going to name the bases, faces, edges, vertices like we did for part A, right? Okay, but then for part B, or for skills practice, these 3 on the back side, you're only going to tell me how many there are of each, right? Like we did for part C, okay? Which one of those do you not have to do anything on for 1, 2, 3 on the back side? Yep, which one do you not have to do anything on? 3, because he is not a polyhedron, he is a what is that thing? He's a cone. There you go. He's a cone. So the other two, just tell me how many there are. You don't have to name them. Make sense? Good? All right. I'm trying to make life a little bit easier for you. Okay? There you go.